So for the topic Gauss-Jordan method, this method is a variation of Gauss elimination. It must also uses the matrix technique. This part, as you see, you have a different transition of the number and combination. So the major difference between the two is that when an unknown is eliminated in the Gauss-Jordan, it is eliminated from all other equations rather than just the subsequent ones. In addition, all rows are normalized by dividing them by their pivot elements. So for this row represents as R1, this one is R1 and R3. So you have to prove that it is equal to find out what X, Y, and Z is. So for this part, for the example, this you have to multiply it by 1/2 to become 1, 2, 4, and 3. 1, 1, 1. Copy the next. So 8 and 12. So for this part, you have to, as you can see, you have to put some techniques on it. You have the equation R2 minus R1 to become copy the 1, 2, 4, and 0, -1, 3, and 5. And copy again the 4, 8, 12, or 12. So for this row, you have to multiply and apply some techniques. R3 minus 4, R1. And there you go, you have an answer 1, 0, 2, 4, 0, -1, -3, and 0, 0, 1, 3, 5, and 0. So for this, you have, so multiplying this part to -1/4 to become 1 is 1 to 4. Copy again the first part, second part. 0, 0 times is -1, is +1. This 0, 5, and 3. So for the next part, applying to this, you have applying R1. No, you have to multiply it by -1 to the second row and have an answer 1, 2, 4, and it will become +3, -5, and 3. So 0, 0, 0, 1. And for this part, you have to R1, you have R1 minus 2R2. Now have an answer 1, 0, 0, 1, 0, 0, 1, 3, 1, 0, 0, 1, -3, +3, -5, and 0. For the last part, for the remaining part, you have to use R2 minus 3, R3, and have an answer 1, 0, 0, 0, 1, 0, 13, -5, and 0. There you go. The answer for that is X is equal to 13, Y is equal to -5, and 0 is for Z. Gauss-Seidel method. Here's the example. starting the initial guess 0, 0, 0 using 3 iterations. So, first, you have to check if it is diagonally is 8 plus 4 is equal to 12. So, it is correct. So, 15. 10 plus 2 is equal to 12 again. 12 equal to 6 plus 4 is equal to 10. So, here's the therefore it proves that it is convergent. Convergence. So, by putting some derivation technique, you have by simply cancelling it is 15 minus 8x2 minus 4x3 over 15 for x2, we simply using it is 20 minus 10x1 minus 2x3 over 15. And for x3, you have an value minus x1 minus 4x2 over 12. So, using the iteration with an initial guess 0, 0, 0, we have to substitute negative is equal to, using this, minus 0 over 15 is equal to 1. x2 minus 20 minus 10, substitute by 1, minus 0 is 15 over 15 is equal to 2/3. And for the 3, for the x3, 10 minus 6, 1 minus 4 over 2/3 over 12. All over 12 is equal to 1 over 9. So for the, by checking the previous and the present value 0, 0, 0, 1 or 2/3 and 1 over 9. So by checking the error approximation, obviously for the first try you have a value always with an 100%. So the next part, using iteration 2, you have an present guess 1 for 1/2 x1 is equal, again substituting the value, you have 15 minus 8 to 2/3 minus 4 multiplied by 1 over 9 all over 15. So you have a value 83 over 135. For the next part, 2 x of 2 20 minus, substitute again, 10 for the new value of x1, 83 over 135 minus the previous value for x3 is 1 over 9. So all over 15 again is equal to 368 over 405. For the next try, x sub 3, 10 minus to the present value 6 times 83 over 135 minus 4. Oh, that's a mistake. 2. 8 is 2. So 4 times the previous x sub 2 is 368 over 405 all over 12. So for the new value for x sub 3 is 271 over 1215. By checking the approximation error, you have previous and present 1, 2/3 and 1 over 9. And for the new value is 83 over 135. 368 over 405 and 275 over 1215. For the error approximation of that is true value minus the approximate value 1 minus 83 over 135 over 83 over 135 multiply by 100 is 62.65%. And for the next is 2/3 minus 368 over 405 over 368 over 405 times 100 is 26.63%. For the last part, the third is 1 over 9 minus 271 over 1215 all over that value 1215 times 100 is equal to 50.18%. So you have a guess that possibly estimated on the root 82.65 and so on. So for the last iteration, iter 3 have a new value 83 over 135, 368 over 405 and 271 over 1215. So by simply substituting again and have an equation x1, 15 minus 8, then substitute to 368 over 405 minus 4 times 271 over 1215 is equal to all over 15. You have a value 8309 18225. So for the next is x2, 20 minus 10 times 8309 18225 minus the previous value substitute to 271 over 1215 all over 15. So your new value is 0.9996. Be careful for your rounding of the decimal. So 0, 10, 6, substitute 389, 18225 minus 4, substitute 0.9996 and all over 12. So you have a value 0.9996 0.2721. So for the last part of error approximation E, you have to cancel, you have to minus it to 83 over 135 minus 8309 18225 all over 8309 over 18225 times 100 is equal to 34.85. And for smart error approximation, we have a value 368 over 405 minus 0.9996 over 0.9996, and negative times 100 is 9.09%. And for EA to the third is 271 over 1215 minus 0.2721 all over 0.2721 times 100 is equal to 18.02%. So as we see the transition of the previous percent error of iteration, you have 100% here, and it has to improve this part 0. As you can see, it decrease the value or the percent, so you have to mainly estimate and finally bring down to the value to this part. So thank you.